Good morning, everyone. Welcome to the first session of day 4 of the FDP. We have with us Professor Sumit Kalra. He's from IIT Jodhpur, and he'll be going to present uh, his topic of presentation is blockchain and IoT and application of blockchain technologies. So, handing over to you, Professor Kalra. So,
Yeah, thank you for nice introduction and good morning everyone. I'll just share my screen and then we'll start. I hope my screen is visible to everyone. So we are going to discuss about blockchain and IoT, blockchain technologies and its applications. And it's part of FDP organized by SKIT. And thank you for inviting me. So just a brief introduction about me. I did my PhD from IIT Kanpur. Before that, I worked with Infosys Research and IBM India Research. And my area of interest are software architecture, Internet of Things, and software engineering. Now, you might be wondering with software architecture how I'm going to discuss the blockchain, but you will find it highly relevant when I'll start. And I am working, I have my lab here as Software Innovation Lab at IIT Jodhpur. As a recent work during lockdown, in the first month of lockdown in March, April, we immediately launched this telemedicine portal. The stats are a bit older. Now we have more than 500 patients visited and benefited using this portal. And the key features of this portal is like you don't need to install anything on your system. It works with mobile as a mobile app without installing any app. So and then it's scalable. You can have thousands of video calls simultaneously. And the right portion which you see smartphone based, vital body parameters measurement. That work is in almost in the completion stage, and we will soon integrate with the telemedicine portal. Now, there's an architecture behind every system. Every complex system has some architecture. And since we are going to talk about blockchain and its applications, let's first understand the architecture of the blockchain. I'm sure you have seen similar image in your last 3 days during this FDP. So I'll just quickly brief again to ensure that everybody is on same page. So there's a Alice and are imaginary characters who wants to exchange anything instead of can. Now whatever is this anything, that is a system. And in robust manner, so even once it goes down, you can still recreate the uh, destroyed part from the other node. So you can use replication factor, you can use RAID, you can use cyclic redundancy code. So there are multiple ways to ensure the robustness in a distributed system. So once you want to exchange anything that is stored on distributed system, and we want to ensure that exchange happened, then we call it. if you do only one-sided exchange, we will not call it transaction. So transaction is like a special set of exchange happening between two entities where we ensure that exchange happens either completely or it does not happen at all. Like you must have read it about the transactions in databases. So they have acid property, atomicity, consistency, isolation, and durability. So that has to be ensured in distributed manner now, because the thing which we are exchanging is stored in distributed manner, and after the transaction also it will be again stored in the distributed manner. So once you perform the transaction, then it goes for the mining through consensus. So mining is like ensuring that that transaction has happened and labeling it acceptance from the most of the miners or majority of the stakeholders in the distributed system that that transaction has happened, and then consensus happened. So that is the roughly high level architecture of the blockchain. So can you think of some applications from the blockchain? What kind of applications are possible which can fit into these transactions? So like I said, it can be money, be aware of this Bitcoin, and other types of it can be land, so real estate. So like you must have heard about the land registries coming up, that can be on blockchain based. Then what other applications you can think of? It can be which is one of which is our topic. Of any smart contract, I'm sure you did contact by Dr. Devashish. So any kind of exchange happening on paper right now can be digitized and put it on the blockchain. Now, if you look at all these different application areas, you application area or almost any application area as of now we are using can be on blockchain. Even our this video conference call can also happen on blockchain distributed system. So not a single system is being overburdened. But then we can always ask question whether actually this video conferencing system or say IoT system or land registry or money is like this. So are they actually fit for blockchain architecture or not? If you refer to the discussion happening around 2018 or 19, there was a lot more hype on blockchain that it can solve almost all the existing problems. And you might have heard about different application domains in your last 3 days. So today we are going to critically discuss whether the particular use case is really suitable for blockchain architecture. If yes, how? If not, why not? And then we will look all these questions in the context of IoT application. I request moderators, if there are any questions coming from the audience, please feel free to interrupt me in between and discuss the questions whenever they are relevant.
Okay, sir.
So, when do we need blockchain? So, I have picked this framework from World Economic Forum, which talks about what are the good use cases to use blockchain, when you should prefer, when you should not prefer. So there are some set of questions, and correspondingly we navigate on different types of blockchain solutions. So we'll look each of these one by one. First one is, the first question we should ask ourselves is, are we trying to remove intermediaries or brokers? Like in this conference call, we have moderators who are working as intermediaries or brokers. So they started this video call session. I was able to join this video call. You were also able to join video call. So there is some broker or intermediary between right now, between a speaker and the audience. In the same way, you can think of banking sector applications, or you can think of some other applications as well. Any blockchain smart contract based applications also. So the first question we should ask, whether we really need brokers or not. If there are brokers, what is the drawback of having those brokers? And for example, there are uh, banks, some banks are public sector banks, and some are private sector banks, and some are cooperative banks. Now, we have recently seen, not recently, it's happening almost every year, that some of the cooperative banks fails, they go bankrupt because of mismanagement or so. Now, who suffers at the end? The end user. Their money got blocked, or they have limited access of money, or the burden goes on to government, and government ultimately uses taxpayers' money. So ultimately the burden comes on the society itself. So is it good choice if we remove all these banks as mediators, intermediaries? Because if we remove these banks as intermediaries, then we are reducing the chances of these bank failures, intermediary failures. Of course, there are some trade-offs. So first question we need to ask, whether we are actually trying to remove intermediaries or brokers or not. If a use case scenario says that broker is necessary, uh, without broker or an intermediary, we cannot execute the transaction, or we cannot execute the transaction trustfully, then we say that we cannot use blockchain. If we say yes, we want to remove intermediaries and brokers, then quest is not over yet. We need to jump to the next question. Is asking, are you working with digital assets as compared to physical assets? Like in the initial discussion, I explicitly mentioned that the anything can be anything, but it has to be a digital form. If it's not in a digital form, it's a physical asset, then we cannot apply our blockchain solutions. For example, say we want to track the production of wheat and consumption of wheat. So rice or wheat, we want to track the supply chain. demand and supply in the market. So what happens with the wheat? It comes from farms, it goes into godams, cold storage, it goes to some factories, converted into breads, or it goes to individual end users, it converted into chapatis. So wheat is actually being transformed from one form to another form since its inception to consumption. But we cannot use blockchain to track the complete demand and supply of wheat because this physical asset is changing the form. It sometimes it's in raw format, sometimes it's in flour format, or sometimes it's in the bread format. So it's changing its form. It's a physical asset. So blockchain is not a good solution to implement the tracking based applications. Tracking of physical assets which changes the form with time, which can change the form with time. So if the answer of this question is no, then blockchain is not a fit. If yes, then we go to the next question. Can you create a permanent authoritative record of the digital asset in the question? So like in the previous slide, I talked about the wheat. So wheat is the asset. Suppose we have digital replica of wheat. So we have digital twin of the wheat. So now question we are asking is whether that digital asset can be recorded permanently or it's a transient asset. Let's take example of your WhatsApp message. I'm sure almost all of you are using WhatsApp nowadays, and recently we are seeing a new feature in WhatsApp. The message will be automatically destroyed in 7 days time. Now each message in every conversation is actually digital asset. Now if your group setting says that it cannot be stored more than 7 days, so ultimately your digital asset cannot be recorded permanently forever. So it's a self-destroying messages, or you can think of any other example such as say uh, say this video conferencing records. Although video conferencing, this live interaction happened, but is it the use case we would like to make it permanently stored and reuse it as again, uh, for other talks? That may not be good use case given that we are replacing the live interaction. So playing the repeated videos, recorded videos is not the good fit. So in this question we are asking, although you are having digital asset, so because the yes come from the previous question, which is saying that are you working with digital asset? It says yes. Then now we are asking whether your digital asset is supposed to be permanently stored or not. At the same time, we are also asking another question. Even it can be stored permanently, do you have authority to permanently store that digital asset? For example, say I I went to attend a meeting. This much information is fine, but what was discussed in a particular meeting should not be digitally openly available to everyone because it can lead to privacy breach. But the meeting convener or coordinator may be having those minutes of meeting with them. So when you have authority to permanently record the digital asset or not, accordingly we will decide whether to go for blockchain or not. So in case if your answer is no, you don't want to store your digital asset permanently or you don't have authority to store those records permanently, then we will not use blockchain. Otherwise, we'll go to the next question. Here we are asking, do you require high performance rapid transactions? Rapid transactions or high performance means it can refer to any interactive applications. Like in this video call, it's an interactive applications. We need immediate responses. And if it's rapid transaction also can be in case of banks, like whenever you transfer money, you want that immediately that money should be transferred to the recipient account. High performance means it ultimately translates into interactive responses. High performance means committing a part of transaction or a part of a statement, executing it, making it persistent. The requirement is in high performance in few milliseconds or microseconds or not. Like one example we have already discussed about this video call. It's a interactive video call. Another example of interactive and high performance domain is your mobile advertisement. Say you are visiting any website or portal, and generally if you visit any website for reading news and all, you mostly you stay for 5 to 10 seconds on the page and then you scroll up or scroll down till unless you are not reading the full article. So now from the advertiser's point of view, uh, they have only less than 100 millisecond to respond to your queries, including the network latency. Suppose I visited a news article on this Goa. So Goa is a tourist place, and advertiser will see that I am reading an article on Goa. So they might would like to show me the advertisement related to some tourist place in Goa or some hotel in Goa. Now, the moment I landed on the page related to Goa, from the moment I will move away from that page, within that time only, the advertiser has to identify the requirement from my current page that I'm visiting the Goa page. Let's put some advertisement related to Goa tourist places. Transfer the advertisement from their server to my mobile network. Show me, and when I change the page, again perform the same task. So in this case, if you include the network latency on mobile data, ultimately the service provider have less than 10 milliseconds out of 100 milliseconds to analyze your data, decide what I need to be shown to you, and then transfer it. Actual transfer of the content from uh, mobile user to server and server to mobile user, the advertisement content will take more time because of network latency. So these high performance applications such as showing the correct advertisement, or if I want to immediately transfer money without any lag, then blockchain is not suitable as of now. So it says that if you need high performance and rapid transactions, the blockchain as of now cannot do these high performance transactions efficiently, but researchers are working towards building more suitable solutions. You might have heard about proof of work, proof of stake. So there are different paradigms coming up where we are reducing the commit time. So we also want to strive for high performance in blockchain transactions as well. If answer is no, you are not looking for high performance, but you have digital asset which you can record permanently and you want to remove brokers, then we arrive to the our next question. We intend to store large amounts of non-transactional data as part of solutions. Previously, we talked about the transactions. Transactions are generally live. They are something interactive in general. So after the transaction happened, then once the transaction is over, the effects of that transaction on any data is made permanent. So persistent storage. So in that case, we are talking about when we are storing those transactions permanently and related metadata. So we are asking whether you have requirement for large amount of non-transactional data to be stored or not. If yes, then again we'll come to the conclusion that solutions are not efficient. So non-transactional data is generally, you can consider stream data, which is being generated from your mobile asynchronously. And so as a part of solution, whether we have requirement of storing the large amount of data which is non-transactional. In the previous question, we talked about the rapid transactions with high throughput, high performance. So if we have high throughput, the amount of transactions will automatically increase. Here we are checking whether it's transactional requirement or non-transactional requirement. So the answer is no. You move towards more transaction blockchain based solutions. So now the next question we are asking is, do you want to rely on a trusted party or do you need to rely? Now, like I already posed this question whether you want to remove brokers, and if you don't want to remove brokers, are you rely on brokers third party or not? So like in case of land exchange, you can see there are lots of dealers and there's a sense of untrustability or non-reliance. So if that is the case that we need a trusted party, then we say that blockchain may work, but we need to further look into the other considerations, like for example, the banking applications. So we need a trusted party. Yes, we need trusted party in banking transactions for compliance or liability reasons. So answer is yes, blockchain may work in banking or finance sectors, but with a word of precaution. we need to still work out lots of details in the banking transactions, such as your um, general finance regulations from Government of India, RBI's watch on all the banks. So we need to further see whether the blockchain kind of currency is actually suitable for the having trusted party or not. So once you say no, we don't want to rely on trusted third party, then we ask another question to ourselves whether we are managing contractual relationship or value exchange. So if it's no, we are not managing any contractual relationship. Again, we say blockchain may work, but then again there are other things need to be considered. And when we say yes, we want to uh, manage contractual relationships. Then we move to next question. So contractual relationship is ultimately your smart contracts or your money transactions. So ultimately contract is happening between two entities. So the relationship between those two entities are contractual. As compared to if you look at the Facebook or any other social networking, the communication exchange is not contractual. So the endpoints for any social networking transactions are actually not bind to respond or to entertain your queries. So they are in free relationship as compared to contractual relationship. If answer is yes, that we are looking for contractual relationship and we cannot trust third party, then we are asking next question whether whatever you are exchanging, it's only in read-only format or also require write access. So write access is much more complicated to share among multiple stakeholders as compared to read-only access. So now we are asking a question whether you require write shared access. If not, blockchain is uh, maybe suitable solution, but we need to look further. And if yes, then we go to next question. Do contributors know and trust each other? Now see, here we have come to the stage where we are talking about that there are multiple stakeholders, multiple contributors, and whether these contributors have trust among each other or not. So if not trustable, then it's a good sign for blockchain. And if it's uh, trustable, so these contributors can actually exchange information without any intermediary requirement or blockchain. So blockchain is kind of replacing the intermediators. Yeah. Now, if answer to this question is yes, then we move further. Are contributors interest in unified or well alignment? So whether these contributors have similar interest or similar concept about anything, so we can ensure that if it's same, then conflict between these contributors may not arise. So we may not need this blockchain-based solution as such. But if it's not the case, that contributors' interests are vary, so they may go to may bluff each other. In that case, it's a kind of necessary to have blockchain or some intermediary. I hope I am quite clear till now. Okay. Let's move to next question. Now, if answer to previous question is no, then ask another question. Do you need to be able to control functionality or not? So if you need a central person or central authority who can control the complete functionality, then we need to see if private public blockchain is good use case or not. If there's a central authority which is expected to control, then we say that we have good use case for private blockchain, so that the private organization, the owner, can actually control the functionality of the blockchain or the complete blockchain system. So if the answer is no, that we don't want any central authority to control the functionality, we move to our next question, which is like, should transactions be public or not? So here we are saying that whatever exchange happening, whatever is the transaction or exchange happening, whether it's okay to make them public or not. If it's not cannot be made public, then again we will go back to the permissioned blockchain or private blockchain. Otherwise, we have quite a strong use case for the public blockchain. So blockchain is nothing, it's a ledger, distributed ledger as such. If questions to all these answers are clear, answers to all these questions are clear, then we can think of the using this blockchain for our solution. If it's not, then we need to look whether it's a good use case or not. And sometimes we may need further research or improvement or optimization here and there in some module of the blockchain. So just to have quick recap, we started with whether we want to remove the third party intermediaries, brokers. Yes. Then whether we are dealing with the digital asset. Yes. Then all these digital assets records can be stored permanently and we have authority. Yes. We are not bothering about the high performance. Okay. Whether we have a requirement for storing large amount of non-transactional data. If not, then we go ahead and check whether we need a trusted party or the things can work without a trusted party. not, then we go ahead, see whether the type of exchange happening between stakeholder is contractual in nature. The stakeholders have either and check whether uh, it also requires shared write access. If yes, then we go ahead and check whether all these end users who are going to use collaboratively this system, they trust each other or not. If they don't trust each other, then we go ahead, we check whether there is a central authority who can have a control on the functionality to be offered. If yes, it's a strong use case for permissioned or private blockchain. And if it's not the case, then we check another question whether the data under these transactions can be public or not. Then if it cannot be made public, then again we need private blockchain. If it can be made public, then we can go for public blockchain. And I'm sure now you are aware what is public blockchain or permissioned ledger or permissionless or like public ledger. So private blockchain and public blockchain. So when we talk about the blockchain applications, now we can again revisit our examples of using blockchain, like whether you want to use blockchain technologies for banking applications or not, or land registry or not, or for video conferencing or not. So like in video conferencing example, uh, we are not looking to have like transactional or contractual properties, contractual relationship between different users, speaker or audience or panelist or intermediaries, right? And we are also not looking at the permanently recording and keeping this digital asset as a part of this class activity and do it repeatedly every month or so, right? So requirements are not there. So accordingly, we'll say that for a video conferencing solution, because it's a high transactional requirement, high performance is required, and then there's no write access, there's no contractual relationship. So blockchain might not be the best solution as of now. In future, we can have tailored customized solution for video conferencing using blockchain, but as of now, it's not the good fit. So now, I whenever you, I suggest that whenever you look at any blockchain-based application, you use this framework and just check whether you really need blockchain or not. Now, why this question is so important, that why do we really need blockchain or not? Even if we don't need, is it okay to uh, use the blockchain? It will be extra overhead, that's fine. If organization is ready to move ahead, then blockchain should be applied. But then, in general, the blockchain is quite expensive in the operational aspect. First of all, it's a distributed system. It requires so many resources. Since it's distributed, the computing power got distributed. But if you really don't require these things, then you need to invest a lot of money without having any extra benefit if you go blindly for blockchain. Not only about the money and effort, but the complexity of system will also increase, the performance will go down, transactional throughput will go down. So there are large number of drawbacks as well as advantages also for using blockchain. So those drawbacks fits well in your scenario and advantages are more critical, then it's strongly recommended that you go for these blockchain based systems. If not, then don't blindly go for the blockchain. I hope this portion is clear about when you need to go for blockchain and when you should not go for blockchain. So as a second part of this talk, we'll now discuss the IoT aspect. So the title of the talk is Blockchain and IoT, Blockchain Technologies and Applications. So first we look at the what kind of applications can be used with blockchain and when you should go for blockchain and when you should not go for blockchain. So now, if you have any question, please feel free to ask.
Thank you, sir. Dear participants, anyone have, if you have any question, please raise your hand.
Your voice is not chat. I'll look. There are some.
Okay, participants, good morning. Now it's clear, sir. Participants, if you have any query, please raise your hands.
In between your question comes, let me know. We'll move to the second part.
Okay, sir, if anyone asks a question in chat box, I will inform you, okay?
Yeah, sure. Yeah,
Sure.
thank you.
Okay, thank you, sir.
So, IoT architecture, like I explained in the beginning that I'm a software architecture person. So, now you know why, how we deal with blockchain in terms of architecture. Now, let's look at the IoT architecture and then we will answer on the similar line why IoT is good fit for blockchain or why not. So in this IoT architecture, you can see that there are some sensors, actuators or smart devices. All these sensors, actuators, smart devices are connected to a gateway and this gateway can be connected to backend directly to servers or it can be connected to a cloud gateway which in turn connected to some backend systems. In backend systems we have variety of use cases such as we can have data streaming processor which takes care of data input stream coming in from various sensors and how to handle the data stream and create a data lake, push it into big data warehouse in more uh, arranged format and use this big data warehouses for having a decision process system in business logic. And this business logic can be accessed through web app or mobile app. So there are different ways. And this business decisions, the policy decisions will derive some controls in your application. So based on the incoming input stream, you want to make some decisions. So control applications will make those decisions. Generate control data which will be given to further the either actuators or output devices. In between, the data warehouse is also used to create large-scale data analytics and to train machine learning models. Once those models are ready, those can be consumed by the control applications to make some decisions. And those control applications will be using the models as well as the current sensor readings to generate any kind of control data. So ultimately what is happening in IoT architecture is there are sensors. Sensors are generating large amount of data. That data can be archived. That data can be in different formats, so we can have data lake. There's analysis being performed on that data. It can be simple business logic or it can be a machine learning model. And combinedly, these business logic and machine learning models can be used to generate control data for controlling the actuator, and the output goes to the endpoints. So that is kind of a general architecture of IoT. Now, once we know that what is IoT and what is blockchain architecture, then we need to see how both of these fits together. So I will use same framework to discuss about the IoT and blockchain suitability. So first question we were having with us is, are we actually trying to remove intermediaries or blockers? Okay. Let's understand the IoT system from different perspective. One, there are some servers. And then there is a sensor. Now, these sensors and servers, they have intermediary known as gateway. Now, I shall ask question, what is the advantage of removing this gateway? Are we trying to actually remove it? Now, in case of IoT, if this is the use case scenario that it's a machine, it's a computing device gateway. If we remove this gateway and put this blue, and remember, blockchain is not a single monolithic system. It's actually we need to see if we put such kind of distributed system in place of gateway. Now these sensors with systems, which may actually block the overrun these limited resources of the sensors. So in this scenario, we may not prefer to remove the intermediaries. Now look at this IoT use case from different perspective. So there's a IoT analytics. Now as a manufacturing unit, say you have some sensors in your factory, IoT analytics as a service. inside. And you can be another manufacturing unit. Say, also having lots of sensors. Also use some analytics as a service. Uh, you want to evaluate the product uh, product's market value, so you need lots of analytics, and we have analytics as a service. Now the concern here is what, since both the industries are using analytical service, there can be some data privacy issue. So if it's a third, then we can have,
So, Sumit sir,
yes,
there are some questions in chat box.
okay, let me check. Okay. As for high throughput, blockchain not solution, but in banking and finance, high throughput is needed. So how we can use blockchain for banking and finance applications? Okay. So this question was very good if we ask in 2018 or 19. But if you look at the recent advancement in blockchain, so in consensus protocol, this is improvement happening. So we are having more real-time consensus protocol. Even if you uh, look at this UPI payment, which I will be discussing in the second half, the time of transaction between two banks is still close to 10 or 15 minutes. The SLA, the service level agreement, is 15 minutes. For your this NEFT transaction or RTGS transaction also, the transaction time is still 15 minutes. And if you are using credit card, the credit card transaction are confirmed even after 2-3 days. So you might be only talking about these ATM based transactions where you immediately withdraw money, or if you do transaction within the same bank or within the same account holder's account, those are quick because they are connected. But in general, in the current banking scenario also, transactions commit takes some time, and that is the reason there are lot more frauds happens in case of credit card, because the moment you perform the transaction and to the moment it got committed, there's generally gap of 2-3 days. So in credit cards, there are two types of transactions: transactions under processing and transactions which are settled. So the requirement of high throughput is needed, no doubt. If you talk about the stock market, I'll say that has much more high throughput requirement as compared to this banking transactions. So to use blockchain in such solutions, uh, we are working on consensus protocol that takes less amount of time. So if you look at the initial blockchain uh, consensus time, it used to take 2 hours or more than that. Again, it's the Bitcoin based solution still takes 2 hours, close to 40 minutes now. But with using the proof of stake, we have reduced the further time to the maybe 15 minutes or 20 minutes. So people are working to improve the throughput issue with the blockchain. I hope the answer is satisfactory. I'll move. So we were discussing that in the second scenario in IoT, where IoT is kind of IoT analytics as a service, where there are different stakeholders who are using the same analytics as a service, and these individual users may have some privacy concerns. So in this case, we would like to remove the intermediaries because we don't want any single service provider to own the data of both the industries and mix up something or leak up something, right? The second question for IoT is, are you working with digital assets versus physical assets? Now there are again different use case scenarios. I and now with different type of sensors, different types of sensors. You imagine generally these sensors are not expensive sensors in case of IoT. It's inexpensive. For example, like in our North India, the northmost India, uh, in Himalayan region, like we generally put these sensors to measure the upcoming avalanche. So whether they're going to be avalanche or not, we spread lots of sensors across the large geography. And every year we need to put new sensors because the sensors which we put last year in April may not be, in working conditions or may not be at all, physically existing now in this April or May. So every year we spread large amount of sensors. Same is true for factory settings also. We deploy a large amount of sensors, but then there are physical wear and tear. Some sensors got old quickly, some others uh, not that quickly. So in these sensors, the question comes to the service provider or manager how to manage these IoT sensors. The sensor management itself is a big issue. Like, well, take example of your tube light in your office or your home. Over the period, the luminosity of your tube light goes down, and the speed of luminosity going down differs for each tube light, even it's coming from the same vendor. So there's some wear and tear happening, which is not happening in the standard pace maybe. The same is also true for different IoT sensors. Now, do we need to use blockchain to manage these different IoT sensors to track their health, maintain IoT based systems for predictive maintenance and so on in Industry 4.0 settings? So If that is the case, since our assets are not are not digital, they are physical assets, they are physical sensors, so the use case is not well fit for blockchain. But on the other hand, if we are looking to manage the if we are talking about to manage sensor data or timeline or streaming data coming from large amount of sensors, since this is then we'll say that yes, we can further explore the uses of blockchain. Okay, so let's next question. So we are moving step by step whether when blockchain is good fit for IoT use case scenarios. In previous scenarios, we mentioned that removing gateway is not a good idea, but if an analytics as a service in case of IoT, then it's a good idea to go towards blockchain. Given IoT analytics as a service, that service, if it's about the sensor management, then again it's not a good idea to use blockchain. But if service is about actual sensor readings, analytics and all, then it might be a good idea. So let's explore further. And the question is, can you create a permanent authoritative records of digital assets in question? All of you are using mobile phones. I'm sure all of you are using mobile or your mobile. There are 5 to 6 minimum like gyroscope, accelerometer, proximity sensor, and all. And with this, you have large amount of software like location can be tracked by Google, Facebook, where you are roaming, whether there are some SMS tracker applications who keep looking at whether you are performing any transaction on your credit card or not by looking at your SMS. So there's lots of software trackers also. Now you can see all these software trackers or physical sensors are actually an IoT data source. So mobile is essentially an IoT device which is actually connecting you with the cloud servers. Now, say for as a mantra, I'm interested in, uh, in knowing that what kind of apparels you generally wear. What is your mood right now? What is the weather in your locality right now? What is the fashion trend in your locality right now? And mobile is the best, uh, you know, IoT device to collect all this data. Because depending on your chat, your sentiments, I can figure it out what kind of apparel you generally wear by looking at your WhatsApp photos, not looking at analyzing your WhatsApp media, your Facebook media. I can judge about what kind of apparels you might be looking for in near future, and accordingly I will suggest you the advertisement, or on Mantra I will suggest you the products, particular catalog. So now the question here we are asking is,
So there is one more question from Jyoti Yadav. I'm audible.
Your voice is not clear. Can you type question in the chat?
Yes, sir. The question is from chat box. It is from Jyoti Yadav.
It's not clear. Your voice is not coming clear to me. There's lots of noise. So I cannot see the question in the chat.
Uh, the question is, if we try to reduce the transaction confirmation, I'm audible, sir?
Yes, now your voice is quite clear.
If we are trying to reduce the transaction confirmation time, then are we really compromise on the security of blockchain?
Okay. So it's a really nice question. See, if you reduce the confirmation of the time, the blockchain is still secure. Understand what is blockchain? Blockchain is a distributed system where you are storing the data. Now, there are different types of security concerns. One concern is whether the data which we have stored in our distributed system, whether that data is persistent or not. So if your transaction confirmation time is reduced, then you can easily confirm the data stored in the particular block is persistent or not. On the other aspect, the security is related to the miners and the distributed nodes which are part of the blockchain system itself. As such, security is not being compromised, but what is being compromised here might be the trustworthiness of the blockchain. We reduce the transactional confirmation time. Say, instead of using proof of work, we are using proof of stake to reduce the confirmation time. Now, proof of stake has some drawbacks as compared to proof of work. In proof of work, all the stakeholders have to confirm whether the transaction is acceptable to them or not. So let's understand it with an example. Say uh, in this talk we have 20 people. Now, if we have to make a decision, now there are different ways we can confirm a particular decision. Either we take vote from all the 20s and wait for yes from all these 20s. So that is proof of work coming from all the stakeholders. In proof of stake, we say whether there is a reasonable stake who are confirming particular decision, then we will go ahead with that stake only. We will not wait for the complete approval. So out of 20, even 11 or 12 people, some majority we can define whether majority is 33% or more than 50% or more than 75%. We can have a confirmation of any decision. And then there is a special cases like the host of this video conferencing call may have some veto power to make some decisions. So although all other 19 people were opposing, but the person with veto power decided to go ahead with the decision, then the decision is confirmed. Those are the drawbacks coming in. So we are not compromising with the security of blockchain, but yes, we are compromising with the third party reliability which is provided by the blockchain. So I hope it's clear. Continue with the IoT IoT use case. So I was talking about your mobile system is actually a good IoT device and which is sending lots of amount of data for you. So now the question is currently we are asking is whether you have authority to record our data or not. So like Google Map provides live traffic estimation. So essentially it's recording all the data on their map, and then based on all the data they give you real-time analytics based on your current data, based on your historical data, based on the historical data from the crowd coming from that region. So, but if you look at this GDPR laws, they have kind of mandate that if you are going to store any user data, even from the website, you need to ask confirmation from the user to accept cookies. And you might be also seeing this accept cookie acceptance notification coming to your websites nowadays. In last one year it is happening because European Union has enforced this GDPR recently for all the websites to get the consent from the user before storing their data, even a simple data also. So in that case, we are asking if we have authority to store our IoT data, then okay, yes, let's go ahead, check whether blockchain is good for us or not. If not, then we cannot use blockchain. Right? Let's move to next question. So now we are asking whether you require high performance or rapid transactions in case of IoT. Now, what could be the scenario for high performance and transaction? So there's a single fire sensor, then we may not be looking for the high performance or rapid transactions. And even in the smart home solution, of course, the scale of the number of sensors is small, reasonably small. So still we are not looking for the high performance. Highly distributed. So now in this scenario, Indian Railways distributed large scale systems, and it's also real required. So real time requirement is there. So here the IoT system may not be preferring blockchain because it's although it's a distributed, it's a scalable system, but then it requires some decisions for IoT sensors data in real time to be processed. So blockchain may not be efficient solution right now, but let's wait for the future versions of blockchain. Let's move to next for IoT. So do you intend to store large amount of non-transactional data as part of solutions? Now, in case of generally the IoT, if it's a spread over, generally data is large scale. So large scale, the large amount of data is for sure there. But then the question or not. Say your location data from your mobile. you're really interested in storing data for all the users for their all the locations 24 hours, 7 days a week, and so on. Because storing a data and the large scale data will translate into uh, let me give you an example, recent example. I hope many of you are using Google for your Gmail or Google Photos or Google Drive. So recently Google announced that from 2021, June or July 2021, they will not support unlimited storage for high resolution photos. And the storage of your photos, videos, backup will be counted against your 50 GB. Now, if your quota is full, you won't be receiving new email, or you won't be able to store the more data in a Google Drive. And if you want to have more data, you need to pay. Google have kept this storage facility, highly scalable storage facility, uh, free of cost till now. But the Google biggest issue is right now with their not the storage. Storage are like inexpensive nowadays, so you must have redundant. So you can reliably store large amount of data in RAID format. But the issue is like your data center need to have cooling facility, and then a general average age of a hard disk is 3 years. So if you have thousands hard disk, you can imagine that one hard disk will be failing every day. Now if you have millions of hard disks, then few 10,000s of hard disks are failing every day. And if you visit any data center of Google or Facebook or Amazon, you will be seeing that the regular activities to replace those failed hard disks, reconstruct the lost data. Meanwhile, they have to pay large amount of electricity bill for 24 hours running those facilities to keep them down, cool down and running. So that is one of the reason I can see that Google might be putting the limits on storage nowadays. So now the question comes is whether you really want to store that data, because ultimately the solution is going to be expensive for your organization. So if not, then blockchain uh, may be ideal. Means if you want to store, then blockchain is not efficiently doing it as of now. But if not, in a central system, you can leverage blockchain to store all these large amount of data in distributed manner. So a single entity like Google is a centralized entity. Right now is responsible for managing all the storage. In blockchain, the storage responsibility will be also distributed among different stakeholders of the blockchain. Next question. So, do you want to rely on a trusted party? So, like for IoT, all the data you are sharing with the service providers like Google Map and so on. But let me put this question in another way. Say you do some transaction for buying, say, for paying hospital. Now, bank insurance company or any advertisement company can either read your SMS data about your credit card bill, to whom you have paid, and so on. Or instead of directly they collecting the data, they check with bank. Bank will not tell the name of the person who has paid the hospital bill, but they will enable advertisers or insurance service provider to communicate through system to end insurance or so here the question what we are asking is, do we want to rely on a trusted party? The banks here working as a trusted party, saying that we are agreed to share our transactional details with banks because we don't have any other options. In turn, bank can share the analytics with the service providers of insurance and advertisement. They can use that analytics to generate the advertisement, and through banking system that advertisement comes to us. So insurance or advertisers providers are not aware of to whom particular ad is going to, but here they are going through the targeted advertisement via banking or third party, trusted third party. And why do we require trusted third party? For compliance and liability reasons, right? Quickly look at the next slide. Are you managing contractual relationship or value exchange? So in case of IoT, the contractual relationships like there are to make some decisions forward or not, some kind of decision we are making. Now it's kind of a smart contract. We are looking to see whether all these ABC satisfying particular conditions or not. Then we can do some actuator level task. So if that is the case, then we'll move ahead. If that is not the case, we'll say that blockchain may not be suitable. Now, as part of your like session is ending over on time, so the next 4 blocks which you can see, including the current block, also the all these 5 blocks. So the 5 blocks at the end, the questions are questions for you to answer whether IoT is suitable, blockchain is suitable for IoT or not. Apart from saying yes or no, you also need to explain if yes, why, if no, why not. So like for this question, are you managing contractual relationship or value exchange? For IoT, you need to talk about the different scenarios where IoT can have contractual relationship or the scenarios in which IoT may not have contractual relationship. In the same way, you need to answer whether IoT system requires shared write access in which scenario and when not, whether all the IoT sensors trust each other or not, whether all the IoT sensors or the stakeholders have unified interest or not, whether there's a central authority to control all the functionalities in an IoT system, or all the transactions should be made public or not. So all these 5 questions are for you to answer as part of this session. And thank you. I'm reachable at my mail ID, and for more information about my work and our lab, you can visit my web page. So, thank you everyone. With this, we will end this session. I will be again taking another session based on cryptocurrency and blockchain. I'll hand over to our moderator.
Thank you so much, sir. Thank you, sir, for your coverage the topic with the help of a questionnaire form. Thanks a lot. For the participants, we have a 30 minutes break for now. We will resume here at 12:30. Thank you so much. Have a nice day.